welcome back to my channel. So today we are going to talk about a very interesting topic about the black holes. So I don't know if you know this film, but there was a film, a blockbuster film by director Christopher Nolan, Interstellar. In this film, space-related concepts such as wormholes, black holes, alien planets were depicted in a very scientifically accurate way. But perhaps the most shocking scene was at the end of the film when, in the climax, the main character of the film, Cooper, falls into a black hole. In the film, the name of the black hole was Gargantua. Cooper falls into the black hole with his spacecraft. Initially, everything was black around him. Complete pitch black darkness. But as he falls deeper, he notices some grain-like particles. These particles hit his spacecraft and cause scratches on it. There were some flashes of light, some sparks, and his spacecraft catches fire. He was forced to eject from the spacecraft, and he kept falling into the black hole. And suddenly, he found himself in a five-dimensional space, a five-dimensional tesseract. It was a mind-boggling experience, a place where he could communicate with his past selves by using gravity. Seeing these scenes, you might have wondered if it is actually possible. Does this exist in a black hole? If we fall into a black hole, what will we see? Come, let's try to understand this mystery in today's. Black holes remained largely unknown until the 20th century. A black hole is a region in space where the force of gravity is so strong not even light can escape. From the outside, you can't tell what's inside a black hole. Black holes haunt our universe. The dark centers of gravity that swallow everything in their path. Einstein's theory of relativity. Let's begin with the beginning of this story, friends. The history of black holes isn't very long. 100 years ago, no one knew about black holes. Because Einstein's theory of relativity, black holes were discovered later. Friends, there are two parts to the theory, but when you'll get back to it, you'll find out that there was a difference in the flow of time. This is known as the kinematic time dilation. Not only speed, but even gravity can also result in time dilation, as shown by scientist Einstein in his general theory of relativity. This was developed by him in 1915. The more gravitational you'd experience, the more time would slow down for you. This is known as the gravitational time dilation, and this was depicted amazingly in Interstellar. When Cooper and his team landed on the Aqua planet, 1 hour on that planet equals 7 years on Earth. This happens on the planet because the planet was very close to Gargantua black hole. So the gravitational force, the black hole, impacted the time. To visualize this, Einstein wanted us to imagine a space-time fabric, kind of a mesh, on which all planetary objects are placed. The space-time fabric bends due to the mass of the objects. And when the mesh bends, not only does it attract more physical objects, but it will lead to time dilation as well. And the other forms of electricity such as sound, heat or light, they are affected by gravitational force as well. Yup, that's right. This was another conclusion drawn by Einstein. Gravity affects almost everything. Not only are physical objects attracted by the force of gravitational, it attracts heat, sound and light as well. Guys, do you know what this means? This means that there can be such objects in the universe which have such a high gravitational force that they can completely absorb light. If there are such objects, it means that they'd be completely black. We won't be able to see them because even light can not escape them. Friends, this is what black holes are. But when Einstein presented his theory of general relativity, he conceived the black holes was nearly a theoretical back then, and since live like gravitation and theoretically objects can absorb light were possible. But Einstein did not know that there are actual black holes. In fact, when Einstein was alive, the concept of black holes seemed weird to him. He knew that there can be such things theoretically, but then theoretically, the existence of infinity is also possible. But realistically, practically, he did not believe that such things existed in reality. By the time he passed away, not even the term black hole was invented. An interesting fun fact here, a key point in Einstein's theory of relativity is that light's speed limits gravity's influence. We don't feel gravity's force instantly everywhere. Its upper limit is the speed of light. To use a practical example, suppose that the sun disappeared suddenly. As you know, we'll get to know this 8 minutes later on Earth about their disappearance because it takes 8 minutes for sunlight to reach Earth. But according to the Einstein's gravitational impact, the sun's disappearance will also be felt 8 minutes later. Isn't it very interesting? After Einstein, the theory of relativity was worked on many scientists. There were several equations. They solved those equations and tried to derive the solutions. And by getting the solution of these equations, it was theoretically proven that things like black holes do indeed exist. By the 1960s, researchers and scientists had finally agreed that not only theoretical, perhaps one day realistically we'd be able to see black holes, because these do exist in space. The term black hole was used for the first time by a magazine in 1964, but only after 1967 did the term gain popularity when physicist John Wheeler popularized it. Even though the term black hole sounds quite sensational, it's a misleading name, black hole. It might sound like there's an actual hole in there, but that's not the case. There's no hole in the space. Black holes are formed by stars. So there's some material at the center, but in stars, our sun is a star too. There's a continuous nuclear fusion reaction at their center. These reactions produced heat and light. The heat being produced sends an outward force at the center of the star. There's the force of gravity. This helps the star remain intact and alive. This is how the stars maintain equilibrium throughout their lives. The forces pushing outwards due to the reaction and the forces pulling inwards due to gravity. But these reactions take place when a fuel exists, either hydrogen or helium. The fuel wouldn't always be there. It would get burned up at some point, and when the fuel ends, thinning outwards, any forces and the gravitational force pulling inwards wouldn't be countered by any equal force, so that star will collapse on itself. Because of its own gravity, this will take a long time. By the way, our sun's life expectancy is around 10 billion years, but what happens next depends on the mass of the star. Let's look at the chart of the life cycle of the chart. If the mass of the star isn't high, like if it was a small or an average sized star, it would turn into a red giant. After which it can become a planetary nebula or a white dwarf. But if it was a huge star with a lot of mass, when it runs out of fuel, it cools down and turns into a red supergiant, and then the supergiant bursts and turns into a supernova. After this, a tiny core remains. If the core is tiny, it is called a neutron star, but anything bigger than that, we call it a black hole. Basically speaking, the mass of the star after it collapses due to its gravitational force becomes small and condensed. It can turn into a black hole. Specifically, how small is the volume of the compressed star? For a star as big as our sun, if that turns into a black hole, the diameter of the black hole will merely be 50 kilometers. Can you imagine the volume getting this small? But the interesting thing here is that our sun will not grow up to become a black hole. This was proven by Indian American astrophysicist Subramanian Chandrasekhar. He developed the Chandrasekhar limit value. He said that the maximum mass of a white dwarf can be 1.4 times the mass of our sun, above which it cannot be stable, and the star would either turn into a neutron star or a black hole. But since our sun is under this limit, it is not going to turn into a neutron star or a black hole. There are mainly 3 to 4 types of black holes. So the first one is the stellar black hole. That is the most common type of black hole. The black holes that were created by stars. Scientists estimate that in our Milky Way there are anywhere between 10 million to 1 billion such black holes. Then there are primordial black holes. These black holes are as small as an atom, but their mass is likely that of a mountain. It is an assumption that they are as small as an atom. Friends, these black holes are merely theoretical, hypothetical. We don't know much about these. The third type of black hole is the supermassive black hole. These black holes are enormous, so big that their mass is more than that 1 million suns combined. And it fits into a ball whose diameter is as big that of our solar system. Scientists believe that at the center of every major galaxy there is a supermassive black hole. The supermassive black hole at the center of our Milky Way galaxy is called the Sagittarius. And the black hole in the film Interstellar was named Gargantua, was said to be a supermassive black hole. Additionally, scientists believe that there may be a fourth type of black hole too. Though it cannot be said for sure, the fourth type of black hole will be an intermediate black hole that lies somewhere between the sizes of stellar and supermassive black holes. Although no proof of it has been discovered yet, one thing you have seen in the film Interstellar and the photos that you have seen till now. The black hole isn't like a big black ball that sucks everything around it. Black holes look somewhat like this. Yeah. This is the black hole shown in the movie because it is in HD and more three-dimensional than the photo captured by us some time ago. The first thing that you'd notice in this photo is the orange colored ring that forms around the black hole. This is known as the accretion disk. It has an important feature of black holes. As you know, the gravitation pulls back in black holes is very high. So, due to the gravitational pull, a lot of gaseous matter and debris are attracted towards the black hole and remains floating all around it. Similar to how planets revolve around the sun because of the sun's gravitational force. The difference is that the gravitational pull of black holes is so strong, so strong that the things revolving around it revolves at a very, very, very high speed and gets so heated up that they turn into a flowing fluid-like matter. They literally become fire-like particles. They are hotter than 1,000,000 degrees Celsius. The closer they get to the black hole, the faster they revolve around it. The particles revolve so fast that they get rubbed together and compressed. This causes them to start glowing. They emit electromagnetic radiation, which are mainly X-rays. This accretion disk was depicted very accurately in this movie. The only thing they got wrong was that it is actually not orange. Human eyes cannot see it. X-rays. Human eyes cannot see X-rays. X-rays lay outside the spectrum of visible light. We simply represent it an orange yellowish color so that we can represent it. The real color of this disk would be closer to the blue. In 2019, the first photo of a black hole was taken. Even in this, the yellowish orange color was used to represent the accretion disk. One thing that you can clearly notice in the actual photo that you might not notice in the movie is that the particles on one side are brighter than the other side. There's a simple reason for that. The particles spinning towards us seem brighter to us. The particle spinning away from us seem dimmer. This is due to the Doppler beaming effect. When you see the real photo of this black hole, you can look at the blurred photo and interpret the direction of the spinning particles, the area that is brighter coming towards us and the dim area going away from us. Coming back to the image from the movie, another interesting thing that you'd notice is that the accretion disk gives off an optical illusion to gravity. It makes it seem that the disk covers the top and the bottom of the black hole. It seems like this because gravity bends the light. The area hidden behind the disk, when viewed from the front, the light coming from the area has to move over because it gets bent by the gravity. If you look at the black hole from the top, it will look like a normal round disk. We get this illusion only when viewing the black hole from the sides. Apart from this, when you enter the black hole, you will see a large circle of light. It is a photon sphere. The gravity in this area is so strong that the light starts orbiting the black hole. But what is light made of? Photons. The photons start orbiting the black hole. This means that if you reach the area of the black hole alive, it is theoretically possible to see the back of your head. Since the light is traveling in a circle in the formation of a ring, after this point is the boundary of the black hole. It is known as the event horizon. It is considered to be a boundary after this point. The gravity is so strong that even light cannot escape. Everything is black beyond this point. If you are falling into a hole, you have crossed the event horizon. Theoretically, there is no chance of you escaping. If not even light can escape, how would a human? In the film Interstellar, it is shown that Cooper's spacecraft continues falling into a black hole, crossed this event horizon, and suddenly he reaches a 5-dimensional space. This part of the movie is purely an imagination. It is speculation because we do not know what is inside the event horizon. The producers of Interstellar had hired a Nobel Prize winning physicist to keep everything scientifically accurate. But there are obviously things that are yet to be discovered by science, things that we don't know anything about. For those parts, the movie turned towards the imagination. What will be at the center of the black hole? Einstein's general theory of relativity tries to describe this. In this theory, the center of the black hole is termed singularity. Singularity is the region of a black hole where the center curvature of spacetime is infinite. Do you recall the mesh that I talked about in the first half of the video? In the case of a black hole, the mesh is bent so much that it's stretched infinitely. As we know from the theory of relativity, time, energy, and everything else is affected by gravity. With the increase in the gravitational force, time keeps getting slower and slower infinitely. But what does it mean for time to get slower infinitely? This means that you go inside a black hole, and if you could ever get out of it, the universe outside would have ended for the rest of us. We do not know. We can only make theories. What do you think? There are some interesting theories that are suggested, like we cannot see what's inside a black hole from outside because the light is absorbed into it. One theory says that the event horizon light reflects off at multiple points before reaching singularity. So, is it possible that inside the event horizon things will actually be visible? The things that we have seen for sure about black holes are actually the single photo. This photo was taken by the Event Horizon Telescope on 10th April. This proved the existence of black hole practically. One thing is sure here. If you fall into the black hole, the chances that you will disintegrate into pieces due to the gravitational force are 100, 1 billion, 100%. You will die in milliseconds. Even so, guys, there is no need to be scared of black holes. Earlier, many people had this misconception that black holes suck up all matter, keep getting bigger, and eventually it will end the whole universe. But that's not how it works. As I told you, at the center of each galaxy is a supermassive black hole. And all other planetary bodies and stars in the range of the black hole revolve around it. In the same way, all the planets in our solar system revolve around the sun. The same thing happens at the center of the galaxy, albeit in more powerful manner. As a conclusion, if you maintain a proper distance from a black hole, if you maintain social distancing, and then you will be safe and secure. And the concept of 5 dimension mentioned in Interstellar is actually another interesting concept. Actually, yeah, it is an interesting concept. We can talk about it later in the future. So that's all for now. I'll meet you guys in the next video. Bye bye. And if you like this video, please do like, share, and subscribe to my channel. And don't forget to watch my other videos too. So bye bye. We'll meet you next week.